Hello, today I will prove Legendre's formula about n factorial. Vp of n factorial. This means which power of p divides n factorial, and if this is alpha, means that n factorial is divisible by p to the alpha, but this is not divisible by p to the alpha plus 1. And we will show that this can be generated like this: n over p, floor function of n over p plus n over p square up to n over pk, if the nth representation is like this. Or the Legendre's formula is that n minus sp of n over p minus 1. And what is sp of n? This is the sum of the digits if we write this number n in terms of p. So in this case it will be a0 plus a1 plus a2 up to ak. At first, let's show why it is correct that n over p plus n over p square plus up to n over p to the k must be equal ep of n. ep of n is like vp of n factorial. To prove this, we need to count the number of integers which are multiple of p. So p to the k. Such numbers will be n over p. But maybe some of them are also multiple of p square. So we need to also count integers which are multiple of p square, n over floor function of n over p square, and we will continue this process until we get the number which is 0, n over p to the k. And because we know that nth representation in terms of p powers equals this one, n over p to the k plus 1, this number must be 0. So we don't need to continue this process. This is 0. So the exact formula will be n over p, floor function of n over p plus floor function of n over p square up to n over p to the k. And now show that n minus spn over p minus 1 equals this number. To show this, now let's imagine what is n over p. Floor function of n over p, this would be ak to the pk minus 1 plus ak minus 1 to the pk to k minus 2 up to the last number must be a1, because a0 over p will give us 0. And all numbers will be divided by p. Now let's look at what will be n over p square. This number would be ak to the pk minus 2 up to ak plus ak minus 1 to the pk minus 3. And the last number will be a2. So we will continue this process until we get only n over p to the k. And this number will give us ak. Now if we look at all these numbers, they have coefficient of ak. All second numbers will have coefficient of a to the k minus 1, and so on. So if we look at these numbers, we get in terms of k, ak, numbers 1 plus p plus up to the pk minus 1. For ak minus 1, we will get 1 plus up to pk minus 2, and so on. For the last one, for a1, we will have only a1. And now if we look at these numbers, clearly this number equals p to the k minus 1 over p minus 1. This number equals p to the k minus 1, because this is geometric progression, pk minus 1 over p minus 1, and so on. Now look at the case, what is n? N was ak to the pk plus ak minus 1 to the pk minus 1, and so on. The last number was a0. Now look at what will we get if we subtract n minus s of pn. This number will be ak times p to the k minus 1 plus ak minus 1 times p to the k minus 1 minus 1, and last ones will be a1 minus a1 times p minus 1, and last number will be a0 times 1 minus 1. Now if we look at these two numbers, they are almost same, but the difference is that in the lower case, all numbers are divided by p minus 1. So if we divide n minus s of pn by p minus 1, clearly we get ak to the pk minus 1 over p minus 1 plus ak minus 1 pk minus 1 minus 1 over p minus 1, and so on. Last one will be a1 times p minus 1 over p minus 1, and the last one is a0 times 1 minus 1 over p minus 1. Clearly these two things are same. This one equals what we get here. These two numbers are equal. So we have proved Legendre's formula about the number of powers of p which divides n factorial. So this was all I want to discuss for today. If you got any theorems or facts to discuss, please write in the comments, and don't forget to like and subscribe.